Okay. Hi, hello everybody. I'm Michalis Kamburelis, and I'm going to be talking about Castle Game Engine and what you can do with it. I'm going to present to you actually. We're going to make a small game together at the end of this talk. And yeah, so let's jump in. So Castle Game Engine is an open source game engine. It's available on the website that you can see, castle-engine.io. And what is it? Well, it's an open source game engine. You can use it to develop proprietary or open source game, whatever you like. It supports 3D and 2D, so you can make any kind of games you want. We are cross-platform, which means that we support desktop, which includes Windows, Linux, FreeBSD, macOS, yeah, actually any modern desktop actually that you can imagine, mobile, Android, iOS, and console, and this means Nintendo Switch. And we are using, as you can guess, we are using modern Object Pascal. The whole engine is developed as a clean Pascal code. We've been using Free Pascal compiler for many years, and now we have ported the engine to be available also to Delphi developers. And I'm kind of excited about this talk because I've been asked to do actually the Delphi port so many times during the recent years, and then well, yeah, we finally did it. So this is like the first time I'm actually going to be presenting Castle Game Engine with Delphi, using Delphi. And this work has been done together with Andrzej Klijański, who actually did most of the heavy lifting of porting the engine to the Delphi. He's great, basically. Okay, so let's go in. As you saw, the basic features is 3D and 2D game engine, sure. So one of the critical features of our engine is, along with any other modern game engine, we have a visual editor, which kind of means that you can design your user interface, your 3D and your 2D game elements. You can visually move them around. I will show the demo of it all. And yeah, and it's like a kind of an editor application for the engine. It's like a main application that you're going to be using and calling it Castle Game Engine. But actually, the engine is just a set of Pascal units that are using what you have designed. Now, the Castle Game Engine can be used with any Pascal compiler, which practically means Delphi or Free Pascal compiler, and it can be used with any IDE, which means Delphi, Lazarus, Visual Studio Code, yeah, so, and basically anything goes. The editor runs natively on Windows, Linux, even Raspberry Pi, which is also a Linux running on ARM. Yeah, underneath the engine, the editor is also a build tool, which is a command line build tool. And for example, if you just like using command line, sometimes it's actually comfortable to just call it from the command line. And you can also use it this way from, for example, Jenkins on any other continuous integration system. So you can we actually have a big Jenkins installation connected to our engine where we can kind of build our games for all the platforms supported by Castle Game Engine. After every commit, we just build the entire thing and package it and make it available. And yeah, continuous integration is great. Basically, most of you, all of you probably already know it, and yeah, actually, you can use it easily using Castle Game Engine build tool, which is just a wrapper around the Pascal compiler, of course. All right. So that's like our most important feature, the editor at a glance. One of the important features of our engine is that this was my initial design goal, and I'm kind of proud that we have achieved it. That you can kind of use pretty much any model format you want. So, for example, you can design 3D models in Blender, 3ds Max, Maya. We support standard formats like glTF and X3D. We support sprite sheets using our own format, or Starlink or Cocos. We support Spine 2D animation. We actually support a lot more formats for your data, 3D and 2D data. And that's important because it means that you can make this data in any application you like. In particular, kind of a personal thing, I actually participate. I'm an X3D Web3D member, which is a consortium developing the X3D standard. And I'm also a liaison between the Web3D and Kronos, and I'm kind of talking with people who are making this glTF and X3D standards. And I'm actually working within the X3D standard to make these things consistent. And the practical result of it all is that the Castle Game Engine is like has and will have, this is my goal, a perfect support for standard 3D formats, which right now means glTF and X3D. And this is important to you because it means that you can export your models from any graphical application to Castle Game Engine. All right? So some of the graphic features that we have, and I'm going to be showing a demo, interactive demo of it very soon. So we have a physical-based rendering, which is kind of a modern way of rendering your models. Yeah. So the lighting is applied to your models in a realistic way. We have custom shader effects, so you can, if you know OpenGL shading language, you can implement your own, well, a lot of fantastic effects that you can call in OpenGL. We have our own system for compositing multiple shader effects into one final shader. You can use screen effects, which is like a post-processing. I mean, it is a post-processing effect on your screen. We support things like mirrors, shadows, using shadow volumes, shadow maps, and actually radiance transfer, and a few other techniques actually. More about our features on our website, and I'm going to be also showing an interactive demo of it actually very soon. So before we move further, I kind of want to emphasize that, well, we very much count on your support. We need your support in particular to pretty much hire more people, and this way we get more resources to do more fantastic stuff. So if you like what we are doing, if you like anything that I'm going to show to you today, please do support us on Patreon. It really matters. I mean, it's kind of the thing that makes this engine going. Okay, so now without further ado, let's kind of jump into like a bit more practical way of showing you what the engine is. So basically, I actually made it really simple since today. So if you want to just take the Castle Game engine with Delphi support, if you want to get it right now, then simply click on this button, Windows plus Delphi support, and this will download for you a zip file that contains everything that I'm going to talk about, in particular the Castle Game engine editor and the Castle Game engine units that work seamlessly with Delphi. All right, so go ahead and download it. That's the gist. All right. Yeah, so after you will download the engine, I would say to run some samples, and I'm actually going to run a few of them by myself right now, and to just show you how does it look like. So I'm going to be using Delphi 11, by the way. The engine supports also, the engine should support all the Delphi versions from 2009 and up. We are testing the engine right now with Delphi 11 and Delphi 10.4. But yeah, it should work with a number of other, but still, well, within the last, I guess, 10 or 12 years Delphi releases. All right, so one of the examples I wanted to show you was the play animation, and let's open it. It's just a regular Delphi project. So I'm going to simply do open project. I'm going to go into the Castle Game Engine directory that, well, I have it on my disk. You can download from the zip file that I showed you. And we have a lot of examples. So I'm just going to show you some of them right now. Let's start with the play application. Play animation. Now it's a simple demo that loads a few models and allows you to select an animation defined on this model. And yeah, then you can play this animation. And I'm going to show you very soon how to design such a user interface that you're going to see shortly here. But first, let's just run it and let's see that it works cool. Yeah, it's compiling. It should be shortly. The engine is kind of big, but Delphi still compiles it very fast, actually. So that's, yeah, the speed of the compilation is actually kind of amazing here, right? All right, so this is how it looks like. And at the beginning, we have a two-dimensional skeletal animation from spine. It's actually in 3D because, well, I can actually do this, so I can just rotate it in 3D. And yeah, you can run various animations of it. So for example, right now it's the static initial frame of the model, but I can tell it to fly, I can tell it to switch into idle. The animation can be played looping, it can be played forward or backward, as you can see. You can switch abruptly between animations, but you can also increase the transition. For example, let's make it 0, more or less 0.5 seconds, so half a second. And let's make a smooth transition between flying and idle, okay? Now I'm pressing flying, and the transition is smooth. So this is a simple demo of what you can do with our animations. In this case, on the 2D spine model, you can also load a three-dimensional model. It's a knight with a sword, and it can attack, and it has a number of other animations, as you can see. Notice that the switch between attack and idle is smooth because the transition time is non-zero, I can as well make it abrupt, instant. Alright? And yeah, that's a demo of what we can do. We have also sprite sheets here. You can also load the static image, animations, work on everything in the same way. Alright, so going on. And what did I want to show next? Physics. So let's run some physics demos. So again, I'm just opening a regular Delphi project, going into a physics 3D demo, run it, and after it compiles, give it a second, we will see how it works. And I should also mention, of course, how do we do actually our physics. We are integrated right now with the Craft physics engine from Benjamin Rousseau. I hope I pronounced it correctly. And yeah, it's a cool physics engine done completely in Pascal. And it works smoothly in Delphi and through Pascal compiler. And yeah, we're using it. Thanks to the fact that it was in Pascal, it was, well, extremely easy to integrate. And as you can see, it works actually in a quite cool way. This is a very simple scene to just show you that the collisions between boxes and sphere work and that they all behave in a natural way. Let's actually load some more interesting level, I guess. And let's see that when I'm dropping some things, they fall in a realistic manner. And I'm going to just be shooting a few things around just to show that physics works as it should in the engine. Alright, so that's a short physics demo, three-dimensional physics. Now let's run another demo to show that the physics also works for two-dimensional games. As I'm going to be, I guess, emphasizing throughout this presentation, the engine supports 3D and 2D both. We focus on both, so we don't focus on 3D or in 2D. We really want to make both of these types of games perfect. And yeah, right now you're going to see the physics using underneath the very same API, the very same classes, also the Craft physics engine, and you're going to see it in 2D. So what I can do in this demo is I can play this kind of shooting the balls, the spheres, well, two-dimensional disks actually just, right? And as you can see, when they hit some objects, this object collides with the spheres in a realistic manner. Now, this is not an actual game. You can't actually do here anything sensible. This is just a simple demo that shooting things and colliding things and hitting things, I guess, works nicely. Okay? So that's a demo of physics. What's more, well, actually we have a lot of examples, but what I thought I'm going to show you next is actually a very simple example. It is also a very powerful example because it allows you to load any kind of model that we support and just play with it. And it's called, well, actually we have a few versions of this example in our examples directory. The one I'm going to show you is called 3D Model Advanced. And I'm just going to go into the engine examples, 3D rendering processing, view 3D model advanced subdirectory, right? And yeah, just run it like this. And yeah, you shall see that it supports any kind of model format that the Castle Game Engine supports using instance of a class called TechCastle Scene, which is like your gateway to render pretty much, let's say, it pretty much interesting in Castle Game Engine. So everything in 3D and a lot of things in 2D are available through Castle Game Engine, through TechCastle Scene, sorry, class, which allows you to render this thing, interact with it, run animations on it, and so on and so on. So this is a simple car model by Paweł Wojciechowicz from Catastrophe Games. Thank you very much from it. And now let's run some other examples. And then, yeah, what you can take the examples, you can test the Castle Game Engine on a number of things that you can just download from the internet. I mean, that's the entire point of supporting standard formats. So here are a couple of links. Here are demo models from our engine. You have also hunted the internet for a lot of high-quality glTF models, for example, Sketchfab, or some sample models from Kronos. And yeah, so what did I want to show you? Okay, so some helmet. This is one of the standard glTF demos from Kronos. So let's go ahead, let's open it. Let's go damaged helmet. Alright, and it looks like this. Oh yeah, and by default, I actually didn't mention, but yeah, by default you have some default navigation method called examine. So you can instantly use your mouse to rotate your object. As you can see, the light that is by default shining is a headlight, so it's like shining from our face toward the monitor. Just yeah, the light works, the model works out of the box, and to code it yourself, it's really just a few lines of code in Castle Game Engine, and you can go ahead and check out this example. How does it work? Okay, let's open some other ones. I think I want to show you something about shadows. So let's open something from the demos, from the demo models of Castle Game Engine. Let's go here. And yeah, this is an example of shadows that is being cast. These leaves, they actually cast shadow on this wall. I'm going to prove to you that these are actually dynamic shadows very, very soon. Right now, I'm just taking a stroll around the scene. What did I want to show more? Oh, I think I wanted to show some mirrors. All right, let's try this one. So a simple model of the water, animated, and yeah, that supports. It's a mirror. I mean, the thing that you see reflected here on the bottom in the surface of the water, it's generated absolutely automatically from the scene above. If you would have something animated above, it would be reflected in the water as you expect. Yeah. Now I'm going to show you to run something called the View 3D Scene. It's a tool in our engine. And this tool it's like no secret. I mean, this tool is really using the same Castle Game Engine API, just the Castle scene to view the models. So what I'm going to show you right now is also available in that simple demo that I showed you like a minute ago, except there was no way to edit the lights in that demo. And in View 3D Scene we have a simple light editor, and we can do it. So I'm opening a model, looks like this. Okay, so it looks fancy, yeah, but you can say, okay, I have here some shadows, but are they not baked in the texture? Well, they are not, and let me show you. So I'm going to open something called Lights Editor in View 3D Scene, and here you can dynamically edit the lights, and you can see that the shadows behave as they should. Now, there's a gizmo visualizing the light position, it's right here. So when I'm moving this, you can see that the shadows behave correctly, as they should be cast by this light. Okay, you can also modify another light source. In this case, we have a model where there are two light sources that cast shadows, and there's one additional point light just to make things, well, brighter. Yeah? And yeah, so everything here works as expected. All right, and the shadows are dynamic. So I wasn't lying there. Everything I showed you is a dynamic effect that is updated in real time as your scene is updated. Okay, now let's actually run the editor, because now we're going into like a second part of my presentation, I guess, which is going to be a real-time demo of actually how to use the engine, how to use the Castle Game Engine editor to create applications and games. They don't have to be games. That's actually something I wanted to mention earlier. You don't need to develop only games. You can just develop general 3D visualization applications using Castle Game Engine. There's nothing really game specific to what we're doing. We just, well, I guess, think about games most of the time when doing 3D visualization. But you can use it for any kind of scientific, industrial visualizations as well. But that was a digression. Okay, so let's run the Castle Game Engine editor that I have placed conveniently on my toolbar. Okay, and let's create a new project. As you can see, we have a number of templates of a new project to choose from. Once you kind of get more advanced, you will usually start from the empty template, to be honest, and then you can fill it yourself with everything you need. But, well, if you have a need that actually matches some of the ready templates, then go ahead and use one of the ready templates. That's what they are for. We have a three-dimensional model viewer. You have a three-dimensional first-person shooter game. We are going to use this template, and some two-dimensional game with a dragon and a castle and a fancy spine animation. So let's create a new project like this. And this is the custom game engine editor. Now, what's most important, I think, is actually to open containing folder in the Windows Explorer, and to tell you that, well, the custom game engine project is just a regular directory on your disk that you can move around, commit to a version control, and so on. Nothing magic about custom game engine project. At the top level, it contains some project stuff to integrate with Delphi and Lazarus, to integrate with custom game engine build tool, and of course two important directories. You can guess what they contain. The code contains the Pascal code, Pascal units that contain your game. You should place all your content. But actually, you can place your source code in any place around your project, but we strongly recommend to keep it actually contained within the code subdirectory, and that's easier. And then you have the data subdirectory, which is kind of a, let's say, magic directory. I mean, if you will package your game, we have some already options to package your game into various formats. Everything inside your data directory will be automatically packaged with your game. And the data directory contains some user interface designs, the fields with the .castle user interface extension, and some images, and some three-dimensional models, in this case made in Blender and exported to glTF, and some audio files. I'm actually going to turn off the audio for this demo you want to hear me in this demo, not the audio of the game. All right. So so what you can do with it, with these designs inside the custom game engine editor? Well, you can click around here at the bottom of the custom game engine editor, and yeah, you will see the same thing essentially. You can explore your files. In particular, you can, for example, press on some three-dimensional model, and then in the bottom right corner you will see a preview of it. And I know my face is right now kind of obscuring it. Let me make it higher like this. Yeah? So this is the preview of a three-dimensional model. You can also preview an image. You can also preview an audio file. You can kind of play it from this place. And yeah, so you can explore your files. And now, I guess one of the most important things that you can do in custom game engine is you can actually open a design and edit it. And I'm going to do it by double-clicking on the game state play design. We have two designs in this project. One is the menu, which is displayed by default, and it contains two buttons, the play and quit. And then from this menu, you can run the state play. And this is what we are going to be working with throughout this presentation. Yeah, so what do we see here? Well, on the left, you have hierarchy, which are simply the objects that are, well, visible inside your scene. You have user interface elements like custom labels and custom viewports. And the labels are, well, as you expect, just a regular text. You can move it around, you can change some properties of it. And then we also have, oh, make it smaller again. And then aside from user interface, we also have a very important viewport user interface element, which by default is full size. It doesn't have to be full size, so you can drag it like this. So now you can see what is the viewport. It's essentially a two-dimensional viewport inside on your screen that allows you to look into three-dimensional world of the game. It also makes sense for two-dimensional games because, well, yeah, it's the idea of a viewport is still useful for two-dimensional games because you can have a large game world and you're only looking into it through a viewport and the camera is moving and so on. So we do have a viewport, and then you have something called items, which actually contains everything visible inside the viewport. And as you can see right now in this simple template, the items we just contain 5 tech castle scene instance. We have 5 tech castle scene instances inside the viewport. One of them is the level. This is the big thing that is visible here. Let me actually switch into the examine navigation and then look at it from afar like this. Okay, so this big thing is the level. And yeah, we have also, as you expect, these 4 soldiers that are separate castle scene. They can be manipulated separately from code. You can also go inside the scene and manipulate particular shapes inside this, but it's easier to manipulate whole scenes. And yeah, so we have 4 soldiers, and yeah, we can move them, manipulate them, change their properties. On the right side, you have what you would expect. I mean, the properties. It's an object inspector, you know it from Delphi. And yeah, as you expect, also knowing it from Delphi, everything I shown here, this the castle scene, the castle viewport, and so on, these are actual Pascal classes in our Castle Game Engine API. And what you see on the right, these are actual Pascal properties of these classes. So the API in Pascal matches what you see exactly. Yep. So let's actually add one more scene, for example, to it, because I was showing you these demos of the helmet and so on a minute ago, and well, you can use them, you can place them using the custom game engine editor in your scene. So by default, I have added new custom scene, and yeah, it doesn't contain any model inside, so it's kind of empty. I mean, I can move this gizmo, but nothing is actually visible. So let's copy here the helmet that I was showing you earlier, okay? And let's just see that indeed it works like this. So let's take from the glTF sample models damaged helmet. Let's just copy the whole directory into our project. We could also in the custom game engine editor open a file outside of the project, but that's not really a good way to make a game in the end, because you want to refer to things inside your game data that will be packaged along with your game. So it's best to just copy the assets into your project. And yeah, now we have this glTF model that I was showing you earlier. We can open it in a scene like this. And yeah, there you have it. Let's make it larger. You can rotate it around and so on. And yeah, it works as you would expect. And this is the way to kind of compose. This is the way to make a, I mean, this is this is a silly thing I'm doing, but if you do it with some proper idea in your mind, then this is the way to design levels using custom game engine editor. I mean, you just drop a number of custom scenes and into your level. You can arrange them in a hierarchy using the custom transform class, and yeah, you can create a big level from many small assets that you have this way. For now, let's actually remove this the scenes, and yeah, and let's kind of focus on what we can do with these soldiers. Okay, so actually first thing we should do is we should learn how to run this project, because right now it's just showing in the custom game engine editor. There are 2 ways to run the project. One is to hit compile and run from the custom game engine editor, and it will invoke underneath the Delphi compiler, assuming you have configured it in your preferences. So here we have the preferences from the code editor. You probably want to set it to Delphi, and you have the preferences from the compiler, and again you probably want to set it to Delphi in this case. And if I just hit F9 in this case, we will compile the project using the custom game engine editor, and yeah, let me do it. Just let me revert to the walk navigation, because there is a code in this in this demo that actually expects that we have walk navigation. Okay, and what I did right now is I just hit F9, compile, and as you can see, the custom game engine editor is actually running the custom game engine build tool, which is in turn running the Delphi compiler. And yeah, in a few seconds it should just compile our project and then run it. All right. Okay, and there we go. Oh, and I just forgot to disable the music. Let me just open this project now in Delphi then and do our first small edit of the project, which is to disable the music, because yeah, you want to hear me, as I said. So it's a regular Delphi project. We can open a project in Delphi and just go ahead and edit it. The important units are inside the code subdirectory, and if you just want to do something at the very beginning of your game, you go into the game initialize, and you usually edit the application initialize routine. And what we are going to do now is, well, we can disable the sound in a number of ways, but one way is to set enabled of the sound engine to false, okay? So let's run it again then, right? From the editor, just to show you it's possible, and also to show you the log output of our project. You will see what it is in a second. All right, there we go. So first of all, the sound initialization aborted, sound engine is disabled, good. Now, what do we have here? I mean, a lot of lines. So what happened is that the custom game engine ran our executable, and now it displays the log that I'm going to show you in a second how to actually make this log visible by yourself. And this is the default log output of our engine. It shows you some compiler version, platform version, and a lot of information about your graphic card, which is very useful to debug the graphic issues, performance issues. Yeah? And if I press play in the running project, it will open what you expect. I mean, it's the scene that we have been designing or looking at right now, and I can move around and explore it. And the walk navigation is just working by default. All right, so that's one way to run a Delphi project, and another way, as you can guess, I mean, it's a regular Delphi project, as I emphasize. You can also just press run from Delphi and run it using the Delphi debugger. It all works. Custom game engine, from the point of view of Delphi, is just a set of Pascal units, regular Pascal units, and yeah. All right, what did I want to show next? Yeah, so I wanted to show some simple editing of this template now. So let's start with adding a button and assigning an on-click event to it. So that's going to be well, very simple and not really impressive, but you will see how doing these things in custom game editor looks like. So we have a button. Let's make it a bit larger. That's some large padding, I guess. All right. We can assign here a caption. Don't really have much of an idea. And the bottom, as in Delphi, and as in all the design form designer, you know, as in Object Inspector, where every component has a name, and this name is very useful to refer to this component from code. All right, so we have a button. If we would just run the game right now, well, yeah, we would have a button that does basically nothing. You can click it, I mean, but nothing will happen. So let's make something happen. Let's open our game state play unit that controls what is happening within this design, and let's access this button from code. Now, right now, you have to declare this button and initialize it from code. It's not done automatically. It will be. It's a matter of, well, it's a matter of implementing it. But of course, we want to make this thing that I just did, which is manually declare this component in my class. Of course, we want to make it happen automatically. Did I do something wrong here? All right, and now we want to assign an event to it. Well, it's a custom button, so it has an on-click event, and I can say that something should happen when I click it. Let's define a method that's called button click. All right, and what it should do, when I told you about the log that is very useful, it's visible at the bottom of the custom game engine editor. So let's write something. All right, and that's it. And let's run it. And yeah, let's run it from the custom game engine editor because I want to see the log. To be clear, if you run the game outside of the custom game engine editor, the log is still produced. It's just going to a file on your disk in the user's username, local data, application data, and there you will find your log of your application. So the log is written anyway, but it's kind of more comfortable to view it immediately when you are using the application. So I can go to the play, and now I can click this. Oh, it's a large button. Okay, so I can click this button, and yeah, each time I click it, a log clicked is being produced and visible here. All right, so that's your basic stuff. Okay, what we can do next? Well, let's do something more interesting. Okay, so I already shown you how to add a scene to the design. Okay, let's do something more. So my idea here is that, well, right now let's add a health bar to the player that visualizes how much health the player has, and then let's define a box. that is hurting the player. It's like a lava. Imagine you're walking on lava. When you walk on lava, your health drops down to 0. And we are going to implement it in this example. And then I hope I will also have time to actually show you how to make something interesting with the soldiers so that they kind of rotate towards you and shoot some simple missiles. Right? So let's start. Adding the health bar user interface. I'm going to hide this button because it's really large and it's getting in the way. Okay, let's add a new user interface. I'm going to use custom rectangle control, which is really just an area with a color. Let's move it to the top like this. And then let's add a child. A new custom rectangle control. And this child will have a red color. Yeah. By default, this child is just placed within the parent. There's nothing interesting happening. But now what I want to do is I want to position the child relative to the parent like this. And I want to control the size of this child in a way that will allow me to visualize the player current health. So I will use the width fraction and the height fraction properties to make the initial size of this rectangle match the parent. Okay, so it looks kind of boring. Let me add some border to make it contain TV. All right, and what have I achieved right now? I have achieved this thing that I have now the width fraction property. And if I will modify the width fraction property like 0, 1, 0, 2, half, yeah, 1, then this way my health bar is moving and I can this way visualize the player how much health does the player have. So let's now implement it. Easier this way. Okay, let's save the design. Now let's make it actually handled from code. In the actual larger games, you usually want to define a class like tPlayer, and you want to manage the player properties like the health inside this class. But here we are just going to, I have just declared another private variable inside the state called health, and that's enough for this simple demo. Yeah? So we have a way to visualize the player health. Let's say that at the beginning the player has the health 1, and then we always want to synchronize such that the health bar. No, I didn't declare it yet. We always want to visualize the health such that the width fraction corresponds to your current health. So I'm going to do it like this. And here we assume that the maximum health for player is just 1. And this makes things simpler, although of course you could make it in a different way. So now by default, if I run it, nothing interesting will actually happen. Because player health is always at the maximum, okay? So let's make something more interesting happen. So let's define something like a sensor. I mean, I want a box that I can detect then whether the player is inside this box. And if player is inside this box, I want to decrease the player's health. How to do it? So let's go to our items. So let's add a box. It looks like this. And yeah, let's make this box larger. Let me then quickly switch to the examine navigation again. All right, so let's move this box. Let's scale this box. Actually, that's actually kind of right. All right, and it's a large box that even is visible from the bottom of the level. Now, I don't want this box to be actually visible. I also don't want this box to actually collide with the player. I only want to access this box from code, and then I want to tell whether the player is inside this box or not. So let's call it box that hurts. Okay, let's save this design. Let's access it from code. Alright, now I have a box. What can I do with it? Now, each frame, which kind of mean continuously, all the time that the game is running, I want to check whether the player is inside this box. Now, the way to do something constantly within your application, the way to do something constantly within your application is to place it in the update method. Update method is called every time the frame is rendered, which is more or less 60 times per second. You should not depend that it happens 60 times per second, but you can think that it happens always, often, or you can think it happens all the time, kind of, in a way. So, the bounding box, the scene that is called box that hurts, it has something called bounding box. And I can check whether this bounding box contains the player position. I don't really have something like a player position, but I have a camera that has a position, and that's simple enough for this demo. Now, each time the camera is inside this box, I want to decrease the player's health. So, well, I don't want actually to do it in this simple way, because I don't know how often this update will be called. I emphasize, like, it's more or less 60 times per second. But if your game is much slower, or if you're running on a monitor that, for example, supports 144 refresh resolution, then you are going to have something different, so some different frequency of the update calls. Okay. So everything, always, everything that you do within the update call should be scaled by the seconds passed, which tell you how much time has passed in seconds since the last frame, which means since the last update call, just like that, okay? So cool, we have decreased player's health, and now we also want to synchronize with the UI, all right? And that's one thing that we can do. And let's now see that it works. Let's run it from Delphi this time, alright? So I clicked the F9 from Delphi, and yeah. Okay, now our application is running in the Delphi debugger. Let's hit play. Oh, and yeah, I made a mistake of. Yeah, I changed the navigation method. It also, right now, it also changes the navigation method used at runtime. And I don't want that. I actually want to use the walk navigation at runtime still. So let's do it like this, and it's fixed, all right? We are going to fix this. I mean, we are going to have a separate camera navigation for design time and a separate camera navigation at runtime. Right now they are connected, so you kind of have to remember about it. Okay, that's done. Let's hope that it works. So if I will walk over inside this invisible box, my health should begin to drop, and it does. Okay, when I move outside, it again, it's okay again. So okay, okay, and that's the simple way that it works. All right, what can we do more? Okay, so let's first implement something to happen when the player's health drops to 0. And to do this, we can implement another state. So I mentioned that we have right now two states, main menu and play. They all have their corresponding designs in the custom game engine editor, and they all have their corresponding units where you can control what happens. And what we want to do now is create a new state called death. So let's do it. You can do it from custom game engine editor. You can also do it kind of without using this fancy menu that I'm showing you. You can just create a new Pascal unit and then a new design. But it's easier to do it this way. So we create a new state. Let's call it state death. Maybe state game over would be more appropriate. And okay, let's edit the new design that we have created. Let's make a very simple visualization of the player's death, which means that I'm going to just make red, this red. I'm going to just make a red rectangle with a big text in the middle. Alright, let's make it large. Let's make it say game over. Okay, save. That's it. Now, how can we actually use this thing that we have created? Well, the thing is that we have now created a new unit called game state death that describes what happens within the state There's actually nothing here that's happening except loading the corresponding design. But we also have an instance of the state that we can use, and we can use it to switch to the state from whenever. For example, here you can check if my health drops below 0, or maybe I don't know, maybe 0 is also means game over, and I can change my current state into a new state called state death. Now, as I mentioned, the states are kind of similar to what you know as a form in Delphi, except the states can be arranged in a stack, which means that, well, in this case I'm not using it, but in a larger games this could be very useful. So, for example, you could display a menu with a transparent background, and underneath it you could have your game playing or paused. So the states are similar and different than the forms that you know. Okay, so what we have made now, we have made death. So if I walk over it, and I will just wait, and yeah, game over. That's what you made. And alright, what can we do more? Well, I want to very quickly show you how you can edit the logic of the moving creature. So what we have right now in the project is something called the TEnemy class, right? This is a descendant of castle behavior. Castle behavior is, well, it's a behavior. It's something similar to the Unity mono behavior, actually. It's something that you can add to the existing castle scene or castle transform, and it can enhance the behavior of that thing. And the nice thing about doing it this way is that you can kind of add and remove behaviors dynamically at runtime. So, for example, something may be alive, something may be moving, and so on. And you can add and remove this behavior at runtime. Yeah. The main feature of the castle behavior class is just an update method, well, which is executed every frame. It's very similar to the update method of your state. So, what we can do here interesting? Well, let's start by saying that I want my soldier to not look in some boring direction. I want my soldier to look exactly at the player. How to do it? Well, I have world. I can access the world, including camera, from inside this this behavior, and the camera has a position. All right. So how to make something look at something else? Well, you subtract the target position from the initial position, which is the position of this soldier. So like this. Now I actually don't want to use it like this, as simple as it is, because this is a three-dimensional vector. The soldier could look then up or down if the player is lower or higher, and our assets are not really prepared for that. So I'm going to assign this into a variable v, which is of type t vector 3. It's a three-dimensional vector, 3 floating point values. And doing it this way, by zeroing the y-axis, I have effectively made this vector flat. So it's never like that. It's always like that, looking to the left or to the right. And yeah, and this is my direction. I want the soldier to look at this direction. Now, let's go forward, because I'm running short of time. So we implement a few things, and then I will show you kind of the result of it. So the soldier is right now walking and always looking in the direction of the player. What more do we want? Well, we want the soldier to shoot something occasionally. So let's add a variable that says the soldier when to shoot something, okay? So let's make it time to shoot, and this will express in seconds how much time should pass before the soldier fires the next missile. Let's say that the soldier fires this next missile after 1 second, and let's add a small randomization to it, okay, just to make it interesting and just to make the soldiers not synchronize totally with each other, okay? Now, if, and in each update, I'm going now to, first of all, decrease this time to shoot value. Okay, base seconds passed. Now, if the time value, time to shoot, has reached 0, okay, then it means that we should shoot something, because more or less 1 second has passed since the spawning of the object or since the last shot. Okay, so here we're going to shoot something, and then we're going to reset this variable, for example, to shoot after another second or so, okay? Now, how to shoot something? Now, to shoot something, it means just to spawn another custom scene and make this custom scene moving toward the player. So, we can just use, for example, the custom sphere. Yeah, I told about castle scene, right? Because you could also, of course, use here a full well, model designed by Blender, by graphic artist, and so on. I'm not going to do that. I'm just going to use a simple sphere because it's enough for this demo. Okay, so let's spawn a sphere. So approximately after 1 second, with something, we are going to spawn a new sphere, and we are going to add this sphere to the world, because otherwise it would not be visible. Okay, and we want to kind of configure it a bit to have some interesting values. So let me make it a bit smaller than default. Let me also make it yellow, I guess, just to show off what I can. Okay, so that's red, green, blue, and then alpha, opaque, and then let's make the material fog, because this will look better when I don't have any interesting lights. Then the fog material looks a bit better, brighter by default. What more? Now, yeah, let's set the translation of our new missile to match the soldier translation. And same thing with direction. And this should be it. We should have a new missile being spawned each time after 1 second. Let's run the game. Let's see that it works correctly. Now, yeah. The castle TF load time is simply double. It's just an alias to double precision floating point value. Oh, here, just okay, hitting play, and let's see what happens. Alright, the spheres are getting spawned, each soldier along its way. As you can see, they are a bit too low, right? So, okay, and another thing that you should see that is happening and working is that as I move around, the soldiers very quickly, instantly, they are always looking at in my direction, right? Okay, so we have spheres being spawned at the same position as our soldiers. Okay, I can still shoot the soldiers, and the dead soldiers no longer spawn the spheres because of this condition in the update method. Yeah, when the soldier is dead, then the soldier does nothing. Alright, so you have spheres. Let's first of all move them a bit higher, because right now they are spawned at the 0, at the ground level, because that's where the origin of the soldier model is. Make them higher like this. And another thing is to make missiles actually move. To make it, let's define a very simple missile behavior. And this is another instance of the castle behavior class that has a very simple purpose. Move the castle scene, move the parent actually each time along the direction. Alright? You could do it without the castle behavior too. You could make a descendant of the castle scene class. But it's, as I said, I kind of like using castle behaviors now, because they allow you to make this behavior like dynamic at runtime. You can add and remove this behavior. In case of missile, we won't really use this. It will always move towards along the direction. But still, it seems like just a nice thing to be prepared for the future and to make it well, code in a way that is nice, I guess, right? So let's make this thing move along the direction. As always, everything we do in the update should be scaled in seconds past. Let's also just make it a bit faster. Otherwise, it would move with the speed of 1 unit, more or less. Let's think about 1 meter, yeah, but that's a convention just. So right now it will move with the speed of 5 meters per second. And I think it will look okay. Now the one thing that we should still do is we actually want to add make an instance, of this missile behavior, and we want to actually assign it to our missile. And this works like that. So we have a missile behavior, add it. And that's it. Let's see that it works. Now, as you can see, I'm not even paying attention whether I'm running the game from Castle Game Engine editor or from the Delphi. I don't have to pay attention to be honest. It's the same thing. I mean, it just compiles the game. And yeah, you have a number of yellow spheres that are traveling towards. Now, the rest of the ideas I'm going to kind of leave to you because, of course, first of all, you can implement check for collisions between the spheres and the player and make the missiles actually hurt the player, obviously, because then the player could be killed by soldiers. And you can figure out a number of other useful improvements to this, well, silly demo that I made. One last trick. So I have shown you so far how to place the Castle Game Engine how to use Castle Game Engine, how to view it inside a window called Castle Window. And that's one way to use it. Another way that we have not yet ported to Delphi, we have it available in Lazarus, but it will be ported to Delphi very, very soon. And I think it may be important for many use cases, is that you can also use something called Tech Castle Control. And this is a rectangular area that you can drop on a regular form, Lazarus form, Delphi form, soon. And yeah, and Castle Game Engine can render things there, and this way you can do, for example, some scientific or industrial, well, not necessarily game visualization inside a larger application, inside a larger form that has a regular standard user interface. You can play this rectangular area with Castle Game Engine that shows, well, whatever you need. All the features of Castle Game Engine rendering are available there. And yeah, that's it. Thank you. Thank you very much for your attention. And yeah, this session has been recorded, but I am also available live if everything goes well during this session. So fire the questions. And yeah, thank you very much. Please come visit the engine. Check it out for yourself. Please support us on Patreon if you like what we're doing. And yeah, thank you very much. I'm waiting for the questions and enjoy DelphiCon. Thank you very much. Bye-bye.
Fantastic. Thank you. That was a great session. Great to see Castle Game Engine working on Delphi, and a good example on how to use it too. Thank you.
Yeah, thank you very much. Thank you all. I hope I catched all the questions in the chat, in the Q&A. There was a lot of questions, so thank you all for the great words. And I know we don't have time yet, so I just want to tell, if you have any other questions, go to Castle Game Engine forum or Discord. It's a chat. We're available there. Thank you all very much for your attention. Really, thank you.
Great. All right. Yeah. Good point. It's top of the hour. Thank you so much, and we'll see everybody in the next session. Take care.